Hello guys, welcome to Advanced Structural Engineering course. So this course is offered as a core elective for the final year civil engineering students. So this course is basically 3 credit course, and so weekly there will be 3 main lecture and followed by there will be 1 tutorial. So total 4 class per week, and this is total 40-hour class in whole semester. We will complete this whole course, Advanced Structural Analysis. So instructor is I am Sharif Chandra, and here for this class I have opened a Google Classroom. By clicking this link you can get into this classroom, Google Classroom, and here you can apply this access code to access the class. After registering you will get regular updates from me for regarding the course, regarding the reference materials, assignments, many projects, any quizzes, anything, any announcement, everything you will get in the web portal. So always be updated with this web portal. So what is the basic objective of this course? Advanced structural analysis. So this is obviously advanced structural analysis course. So in third year you studied structural analysis course. So this one is advanced course of that. So you will study. So obviously, so whatever you studied in structural analysis, this is our prerequisite for this course. So make sure that before going to coming to this class, you should have clear knowledge about structural analysis. Okay, so what is the objective of this course? Obviously to understand the advanced methodologies to identify and to analyze the structures for complicated in a very complicated load pattern. What you studied in structural analysis, that was elementary thing. That means that was the introduction to structural analysis, where you studied basic tools for analyzing the structure, bending moments, shear forces, deflection of beams using the different methods, and statically indeterminate structures you studied. Then several influence line diagrams and all these things you studied in structural analysis course. So this one is a more advanced course on that. So what is the scope of this scope of the subject course? So basically we'll first couple of classes are dedicated to the review of your basic structural analysis which you studied in third year, and then we'll start our advanced analysis using matrix analysis of structural analysis. So initial some lectures will be on truss, matrix analysis in truss, then there will be matrix analysis in beams, then matrix analysis of plane frames, and matrix analysis of 3D frames, and introduction to structural stability. So these are the timelines. We'll one by one gradually we'll finish, and after completion of this course, what you will understand. So upon successfully completion of this course, student will be able to know to understand the importance of degree of freedom. So I think at the basic structural analysis course you studied what is degree of freedom. So after completing this course, advanced structural course, you will have more deep understanding on what is the degree of freedom and principles of superposition, principles of virtual law, principle of strain energy. Okay, so to transform the stiffness matrix, and using the stiffness analysis, how you can simulate a whole 3D structures, all these things you will understand. And at the last but not the least, you will understand the importance of structural stability. Before analyzing the structure, that is our duty to ensure that structure is stable. Not only it is safe, but it is also stable. Safe in this is I am talking about strength perspective. Your structure may have enough strength. It cannot collapse under the different severe loads, but it can be unstable. Unstable means it can have the stability or redundancy. Support is not good to the structure, so ultimately structure may collapse. So that part we'll discuss on structural stability. So obviously prerequisite of this course is mechanics of solid and basic structural analysis, and a lot more you need is some mathematical tools. For example, you need vector calculus, you need integration, you need differentiation, and you need obviously matrix analysis. So you need to know some matrix operations and that adjoints and transpose, matrix inverse, all these basic things you need to know. So textbook of this course is by Asmal Kasimali, that is Matrix Analysis of Structures. And the reference book will you may use Devdas Menon. He is professor of IIT Chennai, IIT Madras. Advanced structural analysis basically deals with the matrix method of structural analysis. And for structural stability, elastic stability part, structural stability parts, you can use very classical book, that is Timoshenko's book, and R.C. Hewlett for structural analysis, because we will review our basic structural analysis also. So regarding that, you need that. So now let's discuss about the lecture-wise plans. So initial first few classes, I think first 15 classes, 15 lectures we devoted on basic structural analysis. What you studied, you may have missed some classes, or some concept you may have not cleared that time. So we will discuss all these basic structural analysis whichever you have studied, or some portion maybe you missed, so that also we will discuss. So starting with the introduction to structural analysis, different loads on the structures, equilibrium, 7 support conditions, analysis of statically determinate and statically indeterminate, and cables and arches, 2-hinge, 3-hinge arches. Then deflection method using the geometric method, deflection using energy method. So in one class we will complete, in each lecture we will complete each topic, large topics. Basically this is the review part, so we will go very fast in these few lectures, and we will try to complete all the basic topics regarding this. Maybe we can discuss little bit about the matrix, matrix operations, because in the later part you need matrix more, more will dedicate on matrix. So basic operations you need to understand. So then we will discuss approximate statically determinate structures, statically indeterminate structures using different methods. So deflection methods we will discuss. Then moment area method, moment distribution method we will discuss on that. Then we will start our actual advanced structural analysis from lecture 16 onwards. So initial classes there will be 5 lectures on matrix analysis of plane stress. So starting from local coordinate system to degrees of freedom to how to generate structural stiffness. Then some finite element formulation using different virtual worlds, coordinate transformation, and then structural structure stiffness relations, procedure of how to analyze. Then we'll go with matrix analysis for beam. So first part was matrix analysis of truss, then we'll study matrix analysis of beam. So same thing will follow. Then after matrix analysis of beam, we'll discuss on plane frame. Plane frame means there will be only a frame. Plane frame normally we discuss there will be 2 column and 1 beam. So basically this is our plane beam, and there will be load is applying here. So this is, we call it plane beam. So how to analyze this plane beam? Next we will go with 3D plane. So initially we will discuss about trusses. So trusses is nothing but axial and compression members are connected each other. So this is really simple trusses. Maybe and load is already applied on the joint, and these all joints are pin jointed structures. So this one is truss. So basically we will discuss about first our matrix analysis on truss. Then we will go with beams. Beams means basically there will be a beam, and it may be simply supported to different cantilever, and there may be different types of loading conditions, uniaxial or maybe point load, or uniformly bearing. So next we will discuss about beams. So how to use matrix analysis to solve the beams deflections and all these things, slopes, curves, all these things. So next we will discuss, after beam we will go with plane frame, whichever we discuss. This one is plane frame, that is there is 2 columns and 1 beams, and for different loading condition there can be simple point load or UDL or different conditions we will discuss. And after plane beam we will discuss 3D frame. So 3D frame basically, so 3D truss structure will be there, and how to solve this 3D buildings, 3D each beams, each columns, and all these things. So at the bottom there is support conditions. uh, so so this one is your 3D building. So how to analyze the whole 3D structure. So gradually we will discuss all this whole thing. So 3D frames. So and the last topic will be theory of the elastic stability. So we have beam columns. What is beam columns? We will discuss elastic buckling of bars and frames, inelastic buckling, lateral buckling. So all these things we will discuss. And obviously in 40 lectures I may not complete in depth all the topics. So it is expected to you that you should regularly update your knowledge by reading the textbooks which is prescribed in this handout, even for the reference books also. So evaluation scheme, there will be 3 major tests: test 1, test 2, and there will be a semester exam. So whichever we followed last semester, exactly same thing. 15 mark weightage, and test 1, test 2 15 mark, and final is 40 mark weightage. And here more emphasis is given on quiz and mini projects. So basically this evaluation is continuous evaluation. Like quiz is a surprise quiz I will take. So suddenly I can take quiz. So every time you need to update whatever up to that class what I have studied, and even mini projects and assignments, it will be continuous process. Every week there will be assignments, and there will be one mini project also. So obviously in mini project you have to solve you have to write a code using any standard programming language. You can use MATLAB, or even you can use Excel sheets also to generate beams, planes, and space structures. Formulas and all theory we will discuss in our class, but same thing, you have to code it, and you can run the program, and I will give different problems for different individual students, and you may use that you have to write your own programming software, programming of computer program, and you have to solve this problem. That will be your mini project. And obviously attendance policy, you are expected to to have 100% attendance. Although maybe some emergency situation, you may take some day leave, but anyway we will follow exactly 75% attendance. If you do not maintain 75% attendance, you are not allowed to say test 1, test 2, even in the final exam. Ultimately you have to take this course in next semester. So it is always advisable you should make your attendance 100%. So I think last semester we are very particular about the attendance, so make use of that one. And chamber consultation hour, you can come to my chamber anytime. You can discuss any problems. If you have any doubt, any confusion regarding the concepts, problem solving, I can help you regarding that. And anytime if I am available, you can come. Prior to the appointment, you can just make a call to me, and you can come and you can discuss your topics. Okay, so make sure that you have registered in that Google Classroom before joining the class, because from next correspondence, everything I will post in Google Classroom, maybe assignments, course handouts, and everything, course reference material, everything. So make sure that you have registered on that. Okay, so next class onwards we will start our main topic, maybe some initial review of our structure analysis. Okay. So thank you. So I am expecting you in the next class.